Hello everyone, welcome back to the latest lecture session. We were just stepping into wastewater treatment and relevant aspects. Rather, we started discussing wastewater treatment and relevant aspects. In that context, we looked at the general variables of importance or relevance to our particular UG course, right? We looked at organics in the context of BOD, COD, suspended solids, nitrogen and phosphorus, nutrients and pathogens. More or less, these are the parameters we want to decrease or are concerned with in the context of wastewater treatment. And obviously, we also want to understand how much is coming in, right? Only then can I design or look at the volume or estimate how much time the water can or will stay in my particular tank and see if that particular time is good enough or not for the relevant treatment. So let's move on. So we started discussing this aspect and we saw that within the day there will be variation, and depending on external events like rainfall you will have variation, that is typically seasonal variation, and you can have steady state flow, but typically in Indian conditions you will not have that, but within the day certainly you will have variation, and within the season too you are going to look at variation. So to take care of this, you can or people build equalization tanks, as in you are letting the flow come in, and let us say I am building an equalization tank with retention time of 10 hours, let us say, right. What will that help me, let us say, or such, or how will that help me? It will see to it that with if I am having continuous mixing, if I am having it, the concentration is more or less the same within that equalization tank before it goes to my particular unit process. And please note that these unit process, at least in wastewater treatment plant, typically include a biological process where the bacteria are going to degrade or oxidize your particular or help in or catalyze oxidation of your waste, which is the substrate or food for these microbes now. So similar to us, let us say bacteria do not like shock loads, the term is shock loads, or to eat a lot within a shorter period of time or such, let us say, right. So typically we are healthy when we sleep well, right, we maintain our fitness and eat a limited amount and more or less the same amount every day. If you eat a lot within a short period of time or do not eat for a longer period of time, obviously you are going to be affected. Similarly, let us say I would like to use layman's terms and use that analogy or apply that analogy to the microbes, right. So you want to avoid shock loads. So equalization tank will help in that. Other than that, let us say you are dosing a chemical, and typically let us say if you do not have accurate flow measurement devices, or let us say the concentration of your particular compound that you are going to target, let us say is varying, right, you are going to unnecessarily either underdose or overdose, pardon me, or sometimes even underdose your particular compound. So to rule out these aspects, let us say, and have a better functioning or more effective treatment plant, equalization tank can be built. But again, in India at least, sewage treatment plants, people do not go for equalization tanks, but that is another story, right. Here is data from dry weather day, right. So what do we have here? We are starting at midnight to midnight, 24-hour period. As we see, it is peaking around 10 a.m. or such. This is from relatively recent data, I believe. And again the reference is given out here, Metcalf and Eddy, right. This is the 5th edition. So what do we have out here? So we have an increase in the morning, right, when people go through their daily ablutions, and then a decrease during noon, and then again another peak during the evening, and obviously a considerable decrease during the night, right. So that is what you see out here. And the average dry weather flow is somewhere out here, it is 106 meter cube per day, let us say, right. So that is something to keep in mind. And in the previous session, before we ended the session, we were talking about peak factor. That will give us an idea about the peak, let us say. But the peak is not an instantaneous peak, as in the absolute peak for this day is this particular point. Instantaneous peak flow rate is 187, but I am not really concerned with this instantaneous peak flow rates. I am concerned about sustained peak flow rates. Let us say what is the maximum flow that was maintained for an hour or 2 hour period. So let us say the peak hour flow rate, as we can see, is out here, and that we see is, I guess people mention that as 183 meter cube per day. So, this peak factor typically people use, or at least in the developed countries, people look at the 2R maximum, right. Here we have the peak R flow rate. So, 2R peak flow rate, let us say, right. So, that is what we are looking at, as in sustained, for a sustained period, what is the flow rate that was held, the maximum flow rate that was sustained for a given period of time. Here the time is for 1 hour, and for example, here for a 13.5 period, 13.5 hour period, the flow sustained flow rate was 125 meter cube per day, right, for 13 hour or 13.5 hour period, let us say. Obviously, peak flow rate will be lesser when the time frame that we are considering is greater, because it is going to, or we are going to look at the sustained flow rate. Obviously, we will also look at the minimum. So, the absolute minimum flow rate and the minimum hourly flow rate, let us say, right. So, how do you take this, what do we say, variation into consideration when you are designing the treatment plant is of general concern, let us say, right. So, as I mentioned, typically we would like to go for equalization tanks, but in India people do not, but again there are quite a lot of industrial wastewater treatment plants which certainly go for that, and some sewage treatment plants too. In general, it is always better to get the data if you can, but in India data availability is always an issue. So, people go for the average, let us say, right. So, that is something to keep in mind. So, one other aspect is, if we look at the ratio of peak hourly flow to average flow, which will give us an idea about the variation, right. So, if I look at what is this is 106 and this is 183, so right, it is around 1.8 times higher, right. The peak hourly flow rate is 1.8 times higher than my average flow rate. But as you can see, in for smaller communities, right, this ratio will be pretty high, and for larger communities, as you see, as an increasing population, right, population in thousands, please note that, I guess population in thousands here, and also again logarithmic scale. So, out here, right. So, we see that for 1 million or 10 power 6 population, you see that the peak flow rate or the variation is much less, because I guess you have a lot of people, lot of activities. So, the flows average out in general, that is one way to put it, right. So, that is something to keep in mind. India, at least as of now, we are not really capturing, what do we say, this level of population. We are at least certainly out here, or relatively or we are building STPs only for, let us say, this level of population, starting from somewhere around here. As we develop as a country and greater what do we say, capital available for infrastructure development, right, say, we are going to, I guess, look at capturing the sewage from these particular communities too. So, that is one thing to keep in mind. And this is the CPHEO manual, or I am just referring to it for the first time. So, we have a manual, I think it was last updated in 2013, if I am not wrong. It is relatively detailed, at least for the Indian context, and it will give you an idea about the design, the maintenance, the financial aspects and such with respect to the Indian context. So, that is something that you can always look at. So, in this particular table, what do we see? We have the peak factor for contributory population. So, as you see, for population between 50,000 to 7.5 lakh, right, from where we typically, or the range above which we typically start building sewage treatment plants in India, we see that the peak factor is relatively less compared to the case when the population is low. But again, in India, they are not really looking at, what do we say, peak hourly flow rate or 2 hour peak flow rates as they do in the relatively developed countries, because again we are some way off out here, right. Again, if we are looking at the bigger what do we say, populations, you see that the flow averages out, and that is what we see out here. So, again, well, let us just discuss why I need to be concerned about this variation in flow with time. One is obviously the impact on hydraulics. Let us say if you have, what do we say, uniform flows, your particular hydraulics and the relevant machinery are going to last for not hydraulics, the machinery are going to last for longer, or you will really need to be varying your what do we say pump capacity, not capacity, I guess, usage and such, depending on the flow rate and such. So, obviously hydraulics plays a role with respect to the machinery. Other aspect is, let us say right now I have a tank of this size, right, and that is designed for the average flow. But let us say if I have peak flow and my particular design did not take that into account, let us say what is going to happen, I am going to have to increase the discharge, and if I increase the discharge, what does that mean? My wastewater is not spending enough time in my reactor, and thus obviously the discharge standards or the concentration of the organics in my particular effluent or the discharge are not going to be at the level that I desired, let us say, because they are spending lesser time in the reactor. So, these are the aspects that obviously we need to be concerned about. And another aspect is treatment effectiveness, as in we have typically two major classifications, right, preliminary treatment and secondary treatment. Preliminary treatment, we are talking about sedimentation or coagulation and flocculation if used or such, let us say. They depend on gravity, let us say, right. And so, they are not very sensitive to changes in flow, because gravity ever present, I guess, right, or you can easily change the dose. So, their effectiveness is not very much what we say affected or adversely affected by flow or time varied flow. But then you have your biological process in the secondary treatment, right. We talk about secondary treatment where we are looking at removal of the dissolved organics and such, let us say, by biological process or by the microorganisms. So, obviously as I mentioned, they are living what we say things, if I may say so, right, living what we say, right, life, their life. So, they obviously do not want to experience shocks either with respect to temperature or their food, which is our waste. So, obviously you want to look at or minimize shock loading. And the other aspect though is that even without an equalization tank, if you design your particular let us say biological process in such a way that we capture the relevant peaks, right, because HRT, let us say we capture the relevant peaks such that we have for a given outflow or constant outflow or semi constant outflow, more or less you are going to be able to handle the flow for that particular what do we say inflow, even though the peak factor is around 2. So, that way you can rejig the design without an what do we say equalization tank. So, one aspect is that the flow can affect your treatment effectiveness, right. And then let us look at the concentration of the relevant compounds that we are concerned with. Here we have the organics which we are measuring by BOD, and suspended solids, right, and then nitrogen content, and then phosphorus. So, we have different countries and India is out here. So, we obviously do not have, at least these people did not have the data for suspended solids, nitrogen and ammonia and such, right. But at least with respect to BOD, you see that we are relatively lesser compared to most of the what do we say, or they are at the lower end, let us say, right. I guess only Egypt is along with us, at least in these countries. So, we see that it depends upon what do we say the level of development, let us say, is it relatively more developed country or developing country, and the kind of food habits obviously will play a role, right, relatively more what do we say vegetarian or non-vegetarian food intake and such, let us see. And obviously class or purchasing power obviously is going to affect your particular what we say quantity of waste you are going to give out. So, here we have BOD in grams per person, per capita meaning per person per day. So, as you see in India, we are with Indians I guess are relatively what do we say contributing relatively less waste to the nature, right. So, that is something to keep in mind, but obviously with increasing industrialization and increasing purchasing power, even our contribution of waste to the nature is increasing now, right. Another aspect is contribution of human waste in grams per capita per day, but now the information is from that CPHEEO manual that I mentioned earlier. I would suggest that you look that up. So, per day, but again this is relatively more recent now. So, BOD we are now at 45 to 54, COD around 2 times higher, organic carbon and such, let us skip that. Suspended solids 70 to 145 grams per day, and ammonia 2 I guess, total nitrogen, not ammonia, total nitrogen 6 to 12 grams per day. You can understand the relevant what do we say range or masses that we are giving out per person per day, right. And then what else are we typically concerned with? I am concerned with total phosphorus and you see out of that inorganic is around 70%. Again we are talking about ortho and poly, but please note that typically only ortho is relatively is relatively more easily used up by the relevant microbes, let us say, right. And then again we have some information about the amount of microorganisms that are present in sewage, let us say, right. So, what do we have? We have total bacteria, right, remarkably high, coliforms, fecal streptococci, salmonella, and so on and so forth. In this context, I should mention one aspect which I seem to have missed earlier when we were talking about pathogens. As in, when I was talking about pathogens, I mentioned prokaryotes, eukaryotes, and the major differences between them. But what is it, or how am I going to measure them, let us say. I can't measure each of these kinds of bacteria or the pathogens, right. There are a lot of pathogens out there. How can I measure everything now, right? That is not going to be economically feasible. So, obviously, what do? I am going to look at an indicator organism, right. And what is it that this indicator organism should be able to indicate? Obviously, it needs to indicate the presence of pathogens. So, this indicator organism should always be present when the pathogen is present, let us say. Yes, that is one aspect, and the ratio of the concentration of this indicator organism to the concentration of this pathogen should always be relatively constant, right. So, that I get an idea about the actual pathogen based on this indicator organism. And also this indicator organism should be tough and sturdy, it should persist in the natural environment, right. It should not be too fragile to say so, right, and then it should be easily measurable. So, for that we look at coliforms, right, as an indicator. So, total coliforms for wastewater, that is the way we measure it with respect to pathogens. Fecal coliform, right, fecal coliform we use when we are talking about I guess drinking water, right, or I think it is the other way around, right. So, we are going to typically look at total coliform and fecal coliform, right. Again, these are indicator organisms, we have different ways to measure them, let us say, right. And let us move on. So, the amount of wastewater obviously depends on how much water the family or the person is consuming. So, obviously it depends again on the location, the purchasing power of the relevant community and such. Relatively smaller communities, but those with house service connection, 7 to 100 liters per day, and typically 85% of the waste is water consumption is what we presume to be the wastewater that is going to be discharged from that particular house. And relatively higher population with full flushing, let us say, right. We see that it is relatively higher. Again, flushing, as we saw in one of the earlier slides, takes up I think almost 40%, at least 40% of the wastewater generated, or contributes to 40% of the generated wastewater in developed countries. And I believe that is where we will also lead to or end up, I guess, if we do not take different conservation measures or end up adopting relatively more efficient flushing systems. So, communities with population above 100K with flushing system. So, again this is the range, and from here you can get an idea about the amount of wastewater per person per day, let us see. And then we have the masses that we are generating per day, and from that you can get the relevant concentration. So, just for comparison we have this, we have low strength, medium strength and high strength wastewater, I guess. This is sewage treatment or sewage, pardon me, not sewage treatment. So, total dissolved solids, I am just going to look at medium strength for now, 560, fixed and volatile, right. That gives you an idea about the relatively inert and more and the organic content. This is within the dissolved solids, let us see, right. And even within the suspended solids, you will have some organic content, that is obviously seen from here. So, fixed is 43, and here we have organic content that is suspended, right, and here is the organic content that is dissolved, let us see, right, and settlable solids, which seems to be relatively less. Again, units are milliliter per liter, I guess, okay, and all the other units are mostly milligram per liter. And BOD, we see it is around 200, typically in India 150 or such. Then COD is 500, again relatively higher for Indian scenario, yes, 300 or so in India, and nitrogen ranges from 20 to 30, right, and of that typically nitrates relatively lesser, because you need oxygen for them to be formed, and obviously as you can see, organic content or organically bound nitrogen and free ammonia are neck to neck, more or less the same, right. Phosphorus, you see organic, which is relatively difficult to degrade, and inorganic. I guess this differs from the data that was given out by CPHEO for Indian conditions anyway, right. There they mentioned that the inorganic phosphorus was relatively higher, almost 70% if you remember. And then relevant what do we say, other parameters of interest. And then here we have the total coliform and fecal coliform. So, we have considerable what do we say concentrations of this coliforms and different cysts, let us say, right. Again considerable numbers per what do we say 100 ml sample, right, considerable numbers per 100 ml sample. So, more or less in India at least it is 150, again this is the not 150 milligram per liter BOD, and COD typically twice or 2.5 times. But for IIT Roorkee, which I believe I have this, okay, for IIT Roorkee, let us say given and taken in 2019 after the sewerage network was more or less built, right, what do you have? Let us look at the typical value. So, pH fine, BOD obviously on the higher side, COD2 on the higher side, again depends on the what do we say type of what do we say usage too. So, it is not just residential community, you have considerable numbers of what do we say amount of research going on, and the relevant compounds that probably should not be dumped into the sewage are being dumped, but again that is something we are taking care of this year, let us say, right. So, suspended solids, dissolved solids, but at that time there was a rainfall event, that is why this what do we say there was considerable not rainfall event, there was another issue for this dissolved solids, okay. And then nitrogen relatively lesser, right, maybe because of vegetarian community probably, but nitrates are relatively higher for some reason, could be due to what do we say compounds being discharged directly, and then phosphorus, right, and then fecal and such coliform. And these are the guidelines as in after treatment to what level should that be brought down, these are the latest guidelines, okay. And as you can see BOD has to come to less than 10, and that is a considerable ask, okay, and COD also has to come to less than 50 milligram per liter, BOD and COD, right. And fecal 2 or coliform 2, as you can see from 10 power 5 3 order magnitude decrease to less than 10 power 2, right. So, that is something to keep in mind, considerable decrease, and though they do not specify about, okay, they are now also talking about biological or nutrient removal, which was not specified earlier, let us say. So, nitrogen and phosphorus too you have to remove, right. So, we are concerned about organic content removal, we are concerned about nutrient removal, and we are also concerned about the pathogens. And while we take care of this, obviously the TDS and TSS will be taken care of, let us say, right, while we take care of these aspects, right. Let us move on. So, one aspect is concentration, but obviously we are concerned with masses, right. It is not just concentration, concentration is mass per volume, right. So, I need to look at the mass, not just mass per volume. So, I need to look at the flow rate. Flow is how much water is coming in per time, right. So, with that I will get mass per time, let us say, right. So, that is this I guess BOD mass loading, mass per time. So, that is the graph we are typically more concerned with, but for general sewage you see that the trends are relatively similar with respect to flow rate, concentration and the BOD mass loading, right. So, that is something to keep in mind. So, the general standards for discharge, again the relevant schedule and the environmental protection rules first came about in 1986 I guess. And here we have National River Conservation Directorate guidelines, but we will look at that later, okay. So, earlier as I was mentioning, where do I have BOD, okay, suspended solids and such. Obviously, when they are talking about suspended solids, that is why they are, as I mentioned, you need to give the relevant filter size. So, that is why they mentioned the filter size. So, pHs and such is fine. So, nitrogen remarkably higher value, but that is considering the total Kjeldahl nitrogen, let us say, right. Here earlier BOD was 30, Now as I mentioned, it's the discharge standard is 30, not 3010, and COD is 50 milligram per liter, not 250, but earlier as you see it was relatively higher. And then you have concentrations of different heavy metals, but in general in sewage or domestic sewage, if there are no industrial, what do we say, sources, typically you will not get heavy metals. But in India, let us say you have commercial enterprises and what do we say, houses in close proximity, and we do not have separate networks. So, depending on the community and type of work they are engaged in, sometimes heavy metals might be high, and then you will have to look at it, because heavy metals at high concentrations are not just toxic to humans, they are also toxic to microbes. But obviously their threshold is relatively higher, if especially you can design the relevant primary treatment process, let us say. So, that is something to keep in mind, right, BOD, COD, and then I guess we have different, what do we say, standards for fecal coliform and such. And one aspect I guess I should have mentioned earlier too is that there are different standards for discharging into inland surface water like river or let us say lake, and for discharging into public sewers, discharging into land for irrigation or into coastal areas. But in general this is not practiced, okay. And I know that people say that you can use it for irrigation, but the issue is even with BOD of 10 milligram per liter, COD of 50 milligram per liter, you have what we call as or refer to as these emerging contaminants, which are remarkably persistent in nature. So, what happens, they come from our waste, and if we use that for our what do we say, irrigation, they enter the food chain now, right, even at levels of BOD of 10 and such. And that is why I certainly would not recommend it, and sometimes people did try this as in using land for irrigation, and the concentration of this persistent organics or even heavy metals in your food grains or your pulses increase considerably. So, again that is something that should be looked at in totality, right. Discharge into public sewers does not really work in India. In some areas, marine coastal area discharge, yes, we do have that, but as you see the concentrations allowable for discharging into these three particular, what do we say, outlets I guess, is higher. But again, typically we are always concerned with discharge into inland surface water bodies, right. So, that is something to keep in mind. But as I mentioned recently, people have been obviously looking at what do we say, our resources, what do we say, as what do we say, not as limitless, but as something that has a finite limit and something that we should pay attention to. Earlier with relatively low levels of population and industrialization, that was not an issue, but now we are understanding the importance of our resources, primarily let us say water and air. So, obviously as you see, we have the National River Conservation what do we say aspects that we discussed about earlier, discharge guidelines again by Ministry of Environment and Forests. So, what do we have? So, we will just look at the primary aspects. Instead of BOD of 30, though I mentioned it 20, so it is now people are pushing for 10, and suspended solids instead of what is this 50, we are looking at 30. And one aspect with respect to suspended solids is that at least in the effluent, okay, effluent, when you measure the suspended solids, you see that it is in close proximity, or rather not close proximity, correlates very well with the BOD, right. So, that is why if you measure the suspended solids in your wastewater, that is typically not wastewater, I guess the treated effluent wastewater, right, treated effluent from a sewage treatment plant, that typically gives you some idea about your BOD, right. So, that is one reason obviously why you can look at suspended solids in the treated effluent. But one other disadvantage in just looking at suspended solids is that suspended solids can be inert, that have no effect on marine or coastal life or your river, let us say, right. So, obviously you can it is a balancing game out there, right. So, that is one aspect to keep in mind. So, fecal coliforms earlier I guess, and now in I believe they were asking for much lower value, we will look at that. But obviously there is always a rider, or it could be lower depending upon the capacity of the effluent receiving water body. So, different what do we say states, let us say Jammu and Kashmir, Punjab, right, or such have different standards or relatively more stringent standards. But if always it is the issue about, or the issue is about enforcement, how do you enforce. So, again CPHEO guidelines, as I mentioned, MOEF standards, yes, and then we have the recommended values, which are what people are pushing for right now, let us say, right. So, recommended guidelines for treated sewage if it is being discharged into surface water being used as a source of drinking water. But in India, more or less every surface water body is used as a source of drinking water, right. I believe I have the more what do we say, recent guidelines, but before we go further, as I mentioned, we have Delhi out here, Mathura, Agra, Etawah, again huge what do we say, levels of population, and Yamuna flowing. So, this person's sewage after replenishment is going to be this person's drinking water, or water for different purposes. Soon though we will not have enough water, so we are going to end up at the case at least maybe 100 years down the line. Again, they are already doing it in some developed countries, at least in South Africa, where they had no water, right. You are treating it to a great extent such that it can be more or less used as drinking water. Wastewater, you treat it to such an extent that it can be used as drinking water. People have a mental block, but it's just about compounds A, B, C and D and parameters X, Y, Z, and if you are able to bring them down or remove them, they are as good as or better than most of the drinking water that is available out there. So, here though we are not at that stage, people in India are nowhere near what do we say, being acceptable to or being ready to accept what do we say, recycled wastewater for drinking. But here we have it for different reuse, as in for toilet flushing you do not need remarkably treated water, for fire protection, vehicle washing and so on and so forth, let us say. Crops which are eaten raw and cooked, but I mentioned the issues out here. At least in India we can go for toilet flushing because that takes up a lot of volume of water, right. And the issue here is that though you have to have a separate plumbing network, which is what we do not have as of now. So, again different standards are given for this. So, this is the next step I would say in trying to what do we say, minimize our footprint and see to it that the water resources which are finite can be reused by us, right. So, let us move on. So, this is what I wanted to mention. So, these are the standards for the new sewage treatment plants, those that are designed after the relevant notification date. As we see, BOD standards are 10, COD is 50, suspended solids 10, fecal coliform less than 230 and nitrogen and phosphorus 10 and 2, right. Slowly but surely we are pressing for relatively low values, but the issue here is that, let me see if I have space out here. Okay. You know that it is a CSTR, typically mostly CSTR, right, or even if it is a SBR, it is a batch reactor. So, what do we know, whatever is coming in, right. Okay, I should not have mentioned SBR in the same breath, but if it is a CSTR, as in flow is continuous and flow is continuously going out, and if you want to have 10 or less than 10, this has to be operated right such that most of it is less than 10 milligram per liter. Why is that? CSTR, right, whatever is in the what do we say tank or the reactor is what will go out. So, for that you have to have higher HRTs or hydraulic retention times or such. But as we discussed earlier, the CSTR is not really an ideal CSTR. You do not have instantaneous what do we say dilution. But obviously, if you are trying to build a what do we say reactor, going for a plug flow reactor is certainly better because the kinetics are going to be relatively higher, R net for the particular volume. As you can see, R equal to Kc, and the lower I want to achieve, the rate here is going to be very less, right. This concentration, if it is low, rate is also low, rate of removal, right. So, that is an issue that you have out here with the continuous flow systems. But obviously, with SBR, which is a batch reactor or more or less a variation of plug flow, if you want to think of it that way, or with well designed what do we say reactors that are more or less or are similar to plug flow reactors, you can achieve good removal rates. But with conventional what do we say process which are already built or conventional sewage treatment plants, getting to 10 is going to be remarkably difficult, right. So, one aspect to keep in mind is that in this course we are looking at sewage treatment plants, right, or treatment plants for domestic sewage, right, sewage from houses and such. But obviously, you have industrial wastewaters and such. I just wanted to give an example about this, as in general characteristics of oil refinery wastewater. So, what is it? Oil obviously is remarkably high, emulsified oil, hydrogen sulfide is high, right. Again, these, what I am trying to mention here is that there is no one size fits all, but in India again lack of knowledge, I guess, but that is what we are trying to address out here by disseminating the relevant knowledge, hopefully, right. We use one size fits all approach, right. So, that is not going to work out. As you can see, you have different challenges out here. So, you have to modify your sewage treatment plant accordingly, right. Again, chromate and such, or chromium, so different aspects. And then obviously, I guess for coal mines and such, you have different discharge standards and such, right. So, one aspect is it is not just the industries, you have the different mining activities that lead to considerable pollution. So, again that is a grey area now. We are still yet to, what do we say, put in more efforts into those what do we say, polluting sources. But again, we do have the relevant laws, but enforcement and will is the issue out here, right. But again, in this course we are looking at domestic sewage. So, I am done with discussing quantity and quality. We are now going to start looking at the crux of the issue, the treatment plants, let us say, but looks like I am out of time. So, thanking you for your patience, I will end today's session.